In this video, we'll be comparing the densities of 4 household liquids: water, honey, soap, and olive oil by pouring them all into 1 cup. A metal bolt, a piece of sponge, and a plastic cap will be dropped into the cup to see which layers they will pass through. And finally, we should be able to analyze the buoyancy forces involved in the objects and how they compare with each respective liquid.
So after we've poured our 4 liquids into the cup, we can see how they've been settled into 4 different layers, with the least dense liquid sitting on top and the most dense liquid sitting at the bottom. Our density is defined by rho, which is equal to the mass over the volume. And we can see how our olive oil is the least dense liquid, followed by the water, followed by our dish soap, and our honey is the most dense liquid.
So now that we analyzed the difference in densities of our 4 different liquids in the cup, we can now analyze the difference in densities of our solid objects we placed in the cup. So as you can see from the experiment, the sponge and the toothpaste cap settled at around the same spot on top of the water, and then the metal bolt dropped immediately to the bottom of the cup, to the bottom of all 4 liquids. So with this, we can see that the density of the metal bolt is greater than the density of the 2 other solid objects, as well as greater than the density of the 4 liquids. And then the sponge and toothpaste cap settled at the same spot, so they have a similar density, but we cannot assume that they are the same. But we can also note that they have a greater density than olive oil and a less density than water.
So, as Declan previously noted, the toothpaste cap and the sponge sunk through the olive oil but did not sink into the water. So, we placed a fork force on top of the toothpaste cap, and while it did push the toothpaste cap into the water, once the force was removed, the toothpaste cap floated right back into the olive oil at the bottom of it. So based on this, we can create a free body diagram of the toothpaste cap itself. So a free body diagram is a sketch of an object that has a force or multiple forces exerted on it, and this helps us understand the direction of the forces, their magnitudes, and it helps us write equations to find these forces. So the 2 forces that I've drawn acting on the toothpaste cap are the force of its own weight, as well as the buoyancy force coming from the liquid that it was submerged into. The formula for a object being submerged into a liquid and that liquid's force acting back up onto it is the specific weight of the liquid times the submerged volume of the object. So whatever portion of the object that is submerged, it's that volume. Here I listed the specific weight of water, which is 62.4 pounds per feet cubed, or 9,810 newtons per meter cubed. Then we have the force of the weight, which is literally just the force of the weight of the object. That comes from the mass of the object times the gravity constant, which is 9.81 meters per second squared, or 32.2 feet per second squared. So since we saw the toothpaste cap float in the water, it means that the force of the weight is less than the force of the buoyancy coming from the water. That's why it floated. But when it sunk through the oil, we know that the force of the weight from the toothpaste cap is greater than the force of the buoyancy that came from the oil.